Hello everyone, I'm Yuichi Omozaki from Osaka Prefecture University in Japan. I'd like to talk about evolutionary fuzzy markup language-based fuzzy inference systems with feature selection for winning rate prediction in game of Go. This is an overview of today's presentation. Fuzzy markup language, called FML, is the first standard for fuzzy systems. FML is composed of the knowledge base and the rule base. The knowledge base defines the shapes of the membership functions. The rule base is a set of fuzzy if-then rules. This is information about FML-based machine learning competition in 2020. The goal of this competition is to design an accurate fuzzy inference system using FML, which predicts future win rate of itself and present win rate of other AI. I'd like to explain evolutionary FML-based fuzzy inference system with feature selection. A general framework of the evolutionary FML-based fuzzy inference system is proposed in the last competition in 2019. In this year's competition, we newly apply a feature selection method to the general framework. Now, I will introduce an evolutionary FML-based fuzzy inference system in 2019. The proposed method optimizes a rule base and a knowledge base using a generic algorithm. The proposed method is composed of the rule-based optimization phase and the knowledge-based optimization phase. First, the rule-based phase is performed, and it outputs the best rule base. Then, the knowledge-based phase is performed with the best rule base obtained in the previous phase. In this way, the two phases are repeatedly performed to design an accurate fuzzy inference system. This is a flowchart of the proposed general framework. First, initialize the knowledge base by the initial fuzzy sets, and the rule base is initialized as an empty set. Then, a learning data set and an evaluation data set are sampled without replacement from the training data set. After that, rule-based optimization phase is first performed. In this phase, a generic algorithm is used to optimize a set of fuzzy if-then rules. After rule-based phase, the knowledge-based optimization phase is performed. In this phase, a generic algorithm is used to optimize the shapes of the membership functions. In this way, the rule-based optimization phase and the knowledge-based optimization phase are repeatedly performed. For more detailed procedure of the evolutionary FML-based fuzzy inference system, please refer to the last competition video or our GitHub repository. The document for the proposed method and the source codes used for this competition are available on our GitHub repository. For this year's competition, we newly apply a feature selection method to our proposed general framework. We employ a sequential forward selection method. First, we execute our proposed general framework using only one feature. The framework will be executed for each feature, and the obtained fuzzy inference systems are evaluated. Then, a combination of features used in the best fuzzy inference system is selected by the fitness value. After that, the other feature is added to the best feature array by the best fuzzy inference system. And the execution and evaluation for each feature array is performed in the same manner. Finally, if all the features are selected, the feature selection method is finished. and the feature selection method outputs the candidates of the combinations of effective features. I will explain procedure of applying feature selection to the general framework. First, we randomly select a validation dataset from the given training dataset. Next, we execute sequential fuzz selection using the remaining training dataset. Then, some fuzzy inference systems are obtained. Finally, the obtained fuzzy inference systems are evaluated with the validation dataset, and the best fuzzy inference system and the best combination of selected features are selected. We performed computational experiments based on our proposed feature selection. These are experimental settings. We executed our proposed method for two outputs, future dBWR of t plus 1 and present EBWR of t, using these parameter values. We use these initial fuzzy sets in computational experiments. We employ Gaussian shape for a membership function. This table is the feature selection results for the future dB win rate. According to this table, the best combination of selected features is selected by the validation dataset. This figure shows that inferred future dB win rate curves for the training dataset predicted by our proposed method and ELF OpenGo AI. This figure shows that inferred those for the test dataset. For the future dB win rate, our proposed method shows a good prediction ability. These figures are the learned knowledge base for prediction of dB win rate. For dB win rate, these three features are selected by our proposed method. This table is the feature selection results for the present EB win rate. For the present EB win rate, the best combination of selected features is not selected by the validation dataset. There is room to improve the generalization ability of fuzzy inference system by considering the better way to select the best combination of selected features. This figure shows that inferred present EB win rate curves for the training dataset. This figure shows that inferred those for the test dataset. In this figure, some parts of patterns are wrongly predicted. It means that the obtained fuzzy inference system is overfitting to the training dataset for prediction of EB win rate. These figures are parts of the learned knowledge base for prediction of EB win rate. Let me conclude that we proposed an evolutionary FML-based fuzzy inference system with a feature selection method. The proposed method selected effective features and showed high generalization ability for the future dBWR. As a future research topic, we should consider a better way to select a combination of effective features for improvement of prediction ability for the EBWR. Thank you for your kind listening.